Next is the redox reactions in basic solutions. First, you have to write the equation, which would be sodium iodide plus potassium permanganate. So you have to cancel out the spectator ions, which would be sodium and potassium, and I minus MnO4 minus will become MnO2 plus I2. And same as in the acidic solutions, you will have to write the half reactions. And on this side, MnO4 minus is becoming MnO2. First, you have to balance the number of atoms. You have 1 iodine and 2 iodines here, so you have to multiply this side by 2. And then you have the same number of manganese here, so you don't have to worry about it. Next, you have to add the water. On this side, you have to add none because you have no oxygen atoms. You simply have to add electrons. You have -2 charge and 0 charge, so you have to add 2 electrons on this side. And this is the end for this half reaction. For this half reaction, you have 4 oxygens here and 2 oxygens here, so you have to add 2 waters here. Then you are adding 4 hydrogen and 2 oxygen, so you have to add 4 hydrogen here. But this is in basic solutions, so you have to do something different, which is adding hydroxide ions. So you cannot have only hydrogen ions, but you have to add hydroxide ions on both sides to eliminate the hydrogen ions. And you can see that this will become 4 water and it will just stay here. And you have to add up the charges, -1 plus 4 minus 4, which is -1, and 0 plus 0 minus 4, which is -4. And you see that you have to add 3 electrons here to balance the charges. You simplify this equation, which will be MnO4 minus plus 4 waters and 3 electrons, MnO2 plus 2 water and 4 hydroxide ions. You have 2 iodine ions and I2 plus 2 electrons. Then you have to balance the number of electrons in both half reactions. You have 2 electrons here and 3 electrons here, so you have to make them both have 6 electrons. So you will multiply this half reaction by 3 and this half reaction by 2. You get 6I minus becomes 3I2 plus 6 electrons. And then in here you have 2 MnO4 minus 8 H2O, 6 electrons, becomes 2 MnO2 plus 4 H2O plus 8 hydroxides. Then you have to add up these half reactions. And this will be 6I minus plus reactant, this and these, 2 MnO4 minus 8 waters and 6 electrons. And all the products, 3 iodine, 6 electrons, 2 MnO2, 4 H2O, and 8 hydroxide ions. Then you have to simplify the reaction by cancelling out the same species on both sides. You have 6 electrons here and also here, so you cancel them out, and you have 8 water and 4 water molecules on this side. So you have to cancel this out, and you now have 4 water. And the net balance redox reaction would be this right here. You have to make sure you end up with hydroxide ions instead of hydrogen ions like in acidic solutions. So this is the net balance equation. The last topic is combustion analysis. So it asks the combustion of this molecule, 2.78 grams produce 6.32 grams of carbon dioxide and 2.58 grams of water. Find the empirical and molecular formula. And its molar mass was found to be 116 AMU. So first thing you have to do is finding the mass of each element, and which in this case would be C, H, and O. In the original 2.78 grams sample. And in order to do that, you have to know this percent composition of carbon and hydrogen in carbon dioxide and water. So in carbon dioxide, the percent composition of carbon is 0.2727. And in water, percent composition of hydrogen is 0.1111. So you have to find the mass of each element, C, H, and O. So you'll produce 6.32 grams of carbon dioxide. And of this 6.32 grams of carbon dioxide, 0.2727 of it would be the carbon. So you multiply this by 0.2727 and you get 1.7235 grams. So you have 1.7235 grams of carbon. And for hydrogen, you have to multiply 2.58 grams of water by 0.1111 and you get 0.2866 grams of hydrogen. Lastly, you simply can find the mass of oxygen by subtracting the sum of these from the original sample, which was 2.78 grams minus 1.7235 plus 0.2866, and you get 0.7699 grams of oxygen. And then you have to convert these all into moles. Then for carbon, you had 1.7235 grams. So you have to divide this by its molar mass, which is 12.011 grams per mole. And you get 0.1436 moles carbon. And for hydrogen, you divide 0.2866 by 1.008 and you get 0.2866 moles. And for oxygen, you divide 0.7699 by its molar mass 16 and you get 0.04811 mole. And as we did in the sample question before, you have to divide all this by the smallest number of moles, which in this case would be 0.04811. You divide all this by the smallest number of moles, and then you get 3, 6, and 1. Then you just found the empirical formula, which is C3H6O. Then you have to find the molar mass of the empirical formula to compare it with the molar mass of the molecular formula. So molar mass would be 12.011 times 3 plus 1.008 times 6 plus 16, which is approximately 58 AMU. Then you compare this with the molar mass of molecular formula, which is 116, and you know that you have to multiply this by 2 to get 116. So you have to multiply this empirical formula by 2 to get the molecular formula, which is C6H12 O2. This is the end of the video, and thank you for watching.